Okay, everybody, I'm going to walk you through a summarization of Chapter 3, and Chapter 3 is associated with the concept of an equation. So let's just kind of get an idea of what we mean by an equation and why we need to work with equations. So let's consider the following problem. Seafood City's profit on a daily basis is determined as follows. For each customer that walks in the door, they're going to make $20. But there is a flat expense of $200 just for opening up the store. We want to describe, let me get my pen working, we want to describe what the profit is going to be on a daily basis in terms of a mathematical expression. So in other words, we want to take this information and write it down mathematically. So if we're going to convert this to an equation, the first thing we have to do is look at what it takes to determine the profit. Well, for each customer, they're going to make $20. So the first question is, we need to know how many customers are coming through the door, right? Since we don't know what that is, what we need to do is we need to assign a variable to that. So we're going to let x equal to the number of customers, right? Anytime you don't know what a number is, you assign it a variable. So if X is the number of customers, then if you think each customer makes $20 for Seafood City. So the profit from the customer is going to be 20 times X. So that's the profit from the customer, right? All right. Now, there is a cost that is associated with just opening up the store, $200. So the bottom line is the total net profit that they're going to make in any given day is going to be 20x minus the $200 to open up. So now we have a mathematical expression that describes the profit they make on a daily basis. This is called an expression. It isn't equal to anything. Whenever we're given the particular value for x, we can plug it in and it gives us the value for the expression, which is the profit. So for example, how many customers must they have on a daily basis to break even? To break even means you make exactly nothing. You don't lose money, you don't make money. So in other words, I want to know, when is this expression equal to 0? Well, this is exactly what I'm saying here. When is the expression equal to 0? This is called an equation, okay? And what we like to do is try to determine when the equation is true. In other words, if you think about this, if x is equal to 10, you have 200 minus 200, which is equal to 0. In other words, they break even when they get 10 customers. Once they get more than 10 customers, they start making a profit, all right? But anyway, this is what's called an equation. This is the focus of this section, is to try to figure out how we actually solve such equations. Next question, how many customers must they have on a daily basis if they expect to make $500 in profit? So in this scenario, what we want to do is we want to set 20x minus 200 and equal that to 500. Now this one's not so easy to determine what the actual answer is, okay? Because this one here, I mean, plug in simply seeing 10 here, 200 minus 200. So that's why we want to learn how we can actually solve an equation. And that's what we're going to be working towards in this set of lecture notes. So let's move on. Okay. The above is an example of an equation and how it is useful for solving real-life problems. An equation is a statement that two things are equal. Our job is to find solutions to the equation. And what we mean by a solution is a value. When we plug it into the equation, it becomes a true statement. So the values we can replace the x with, and when we do that, we get a true statement. If we look up here, you see, if you look at the very first one here, okay, right here, if I plug x equal to 0, 20 times 0 is 0, minus 0 minus 200 is 0. That's not true. If I plug in 1 here, 20 minus 200 is minus 180. That's not 0. So again, a solution makes this true. So in other words, you just can't go around plugging any number in for x. You have to find the x that works. Okay? And that's where we're going. So let's look at this example here. I encourage you to stop the video, work problems, and then compare what you do to what I'm going to do here and now. So what I'm suggesting is stop the video, try working the problem. All right. Now, here's an equation, and I'm trying to determine which of these values will make this a true statement. Which of these values are solutions? So what I'm going to simply do is, I'm going to take each one. So let's take x equal to 1 first. I'm going to replace the x with a 1. I'm going to simplify it. And once I simplify it, I notice I do not get a true statement. So x equal to 1 is not a solution. I'm going to take x equal to minus 1. I'm going to replace it. Replace the x with the 1. This time I get minus 2 plus 1. I get minus 1 equal to 13. That's not true. So x equal to minus 1 is not a solution. And now I'm going to try x equal to 6. When I substitute 6 in for x, and I simplify it, 13 does equal to 13. That's a true statement. So I have found a solution to this equation. The solution is x equal to 6. Okay? Now we don't really want to do it this way, and that's what we're going to be doing, working on trying to find an efficient way by which we can determine the solutions. Next example. Again, I encourage you to stop the video. Is 2 a solution to 4x minus 3 equal to 5? Well, the way I find out is I replace the x with a 2. I simplify it. And when I simplify it, if I get a true statement, which I did, then the answer is yes. Is 2 a solution to 4x plus 3 equal to 5? Again, substituting. 8 plus 3 is 11. 11 does not equal to 5, so the answer here is no. So now we're going to talk about a little terminology here. The number you add to another number to get 0 is called the additive inverse. When you add two numbers together and you get 0, you say those numbers are additive inverses of one another. Another way of saying it, they're called opposites. For example, since when you add minus 3 to 3, you get 0, minus 3 and 3 are additive inverses, or we're probably going to be saying opposites. 4 plus minus 4 is 0, so 4 and minus 4 are additive inverses. Fraction, the same thing. 1/2 plus minus 1/2, we will soon find out is equal to 0. So 1/2 and minus 1/2 are additive inverses. But again, we often just refer to these things as opposites. In regards to multiplication, when you multiply one number to another number and you get 1, we call these things multiplicative inverses. So 2 times 1/2 is going to be equal to 1. So 2 and 1/2 are multiplicative inverses. 2/3 and 3/2, when you multiply these together, you'll find out that you have multiplicative inverses because they multiply to 1. So we call these things reciprocals of one another. When you multiply two numbers together, the product's 1, we call them reciprocals. So let's go through a couple of examples here. So again, stop the video. Try it out. Alright, minus 2. The opposite of minus 2 is going to be the number 2. Because when you add them, you get 0. The reciprocal is going to be minus 1/2. Minus 2 times minus 1/2 is 1. Remember, you got to get a positive 1. I'm going to make a note about the signs in just a minute. The number 2/5, the opposite of that is minus 2/5. You might not know that yet if you haven't looked at fractions, but again, that's what's going to be happening. The reciprocal, 5/2. The number minus 3/7, the opposite is 3/7. The reciprocal is minus 7/3. The number 5, the opposite is minus 5. The reciprocal is 1/5. So what I want to take note here is that when you want the opposite of something, you simply change the sign. When you want the reciprocal, you leave the sign alone. Notice that the signs are the same for the reciprocals. Okay? But the signs are different for the opposite. So, you want the opposite, change the sign. You want the reciprocal, you flip the fraction, you flip the number. That's what probably most of y'all recall, flipping the number. Numerator becomes denominator, denominator becomes numerator. You always have a denominator of 1, meaning 2 is the same thing as 2/1, so its reciprocal is 1/2. Alright, let's move on. Some more terminology. We define a term to be a product. A term is a product. That's all there is to it. This is very important. You have to understand the concept of a term. So slow down and pay attention because terms are used throughout algebra. You work with terms, so you have to be able to identify terms. A term is a product. So how do you identify a term? Well, they'll have to be separated by addition and subtraction. Because if they're a product, to distinguish a term from another term, there'd have to be an addition or subtraction sign between them. A coefficient is the actual number associated with the term, the number in front of the variable or variables. We're going to walk you through some problems here and find what the term is and then identify the coefficient. So here we go. Again, anytime I come to an example, it's the last time I'm going to say it, I encourage you to stop the video, try working it, and then restart the video. Alright, identify the terms and coefficients in the following. Well, if you want to identify terms, what you do is you look for the addition or addition or subtraction sign. So, here's subtraction, this is a term. The other term is right there. I'm going to say something in the middle. So, in a moment. So, what are the terms? And what are the coefficients? Okay, I think that's a typo there. Alright, anyway, the terms are 3x and minus 6. The coefficients are the numbers 3 and 6. So 3x minus 6 are your terms. 3 and minus 6 are the coefficients. Remember, always associate the sign with the number to the right. Always associate the sign with the number to the right. Okay? Just do it. In our next one, our terms are going to be minus 4x, minus 9, and minus x. Again, terms are separated by addition and subtraction. The coefficients are the numbers minus 4, minus 9. Whoa, now what's going on here? We don't have a number in front of the x. Well, you can always multiply by 1, right? So, it's implying that there is a minus 1 in front of the x. So there are my coefficients. The next one, my terms are going to be 3x minus 8, 2x, and positive 11. So 3x minus 8, 2x, and 11 are the terms. The coefficients are just the numbers. 3 minus 8, 2, and 11. So you need to make sure you understand how to identify the terms, how to identify what the coefficients are. always associate the sign with the number to the right. That's a given. Now, what are like terms? Here's a very important concept. Like terms are terms that look essentially the same except for possibly the coefficients themselves. Terms are like when they are identical except for the coefficients. The key fact here is we're going to be able to combine our like terms by simply adding their coefficients together. Combining like terms by simply adding coefficients together. In fact, you have to combine your like terms. This is a given. Let me get my phone. Okay, we want to identify like terms and if possible combine them. So, like terms look exactly the same except for the coefficients themselves. So what we're going to do is identify our terms first. 7x and 4x are like terms. Because look, they're identical except for the numbers. Minus 5 and minus 11 are like terms. You combine like terms by adding their coefficients together. Adding the coefficients together. So 7 and 4 is equal to 11. X minus 5 minus 11 is minus 16. In other words, this expression is the same thing as this expression, and that's what we mean by simplifying, to make something smaller. The next one, all three of these terms are alike. Notice they're identical except for the 2, 3, and the minus 4. We combine them by adding their coefficients. 2 plus 3 is 5. 5 minus 4 is 1, so we're left with 1x. Explain why the following are not like terms. If you look at these two terms here, remember, the first thing is I have to be able to identify my terms. These two terms are not like because this term doesn't have a y in it. Simple as that. That's why they're not like. You can't do anything with terms that are not like. In other words, this expression is simplified. The next one, these two terms, they're not like, they have the same coefficient, but that's not what we're worried about. We don't care about the coefficient, we care about the variable. This variable x has a 2 for an exponent. The variable x here doesn't have a 2. Remember, if you get rid of the coefficient, they have to look exactly the same. They don't. They're not like terms. So anyway, I'm going to stop the video here. We're going to have another button right here for you to press over here. We're going to have a new button. And I like to cut the videos off into sections just in case something happens, and so you can pick up and you don't have to watch this very long video. Anyway, let me stop the video and then I'm going to just get right into it with another one.